Hello and welcome back to the channel. Today we're going to be unboxing and taking a quick look at the Nokia Fastmile 3. To keep things short and save some times, I'll be doing a voiceover throughout the unboxing instead of showing everything in real time. This is going to be one of those information-focused videos where most of the content comes through my narration, so there won't be a lot of text, graphics, or visual explanation on the screen. If there's anything you don't understand, feel free to leave a comment below and I'll do my best to explain it. Besides the unboxing, I'll also be talking a little bit about what 5G actually is and what the Nokia Fastmile 3 is capable of and my overall experience using it. We'll cover things like network stability, modem performance, band locking, cell tower locking, overheating concerns, and a few other features and limitations that you might want to know before buying one. Before we begin, a quick disclaimer. I purchased this device with my own money. This video is not sponsored and nobody has paid me to say anything about this product. Currently, we're in the fifth generation of wireless networks, better known as 5G. Within this generation, there are three major stages of evolution. You may have heard them referred to as 5G NSA, 5G SA, and the latest version, 5.5G, also known as 5G Advanced or 5G Plus, depending on how your device manufacturer or telco brands it. I'll also be talking about two important technologies that you'll often hear mentioned alongside 5G. That is ENDC and carrier aggregation. Before we begin, I should mention that the road analogy I'm about to use isn't 100% technically accurate, but I think it's one of the easiest way to understand how these technologies works without getting too deep into networking jargon. Let's start with 5G NSA, which stands for 5G non-standalone. This was the first version of 5G that most countries roll out. To explain it, imagine your city is building a brand new highway that is faster, wider, and more modern than the old highway. The old highway represents 5G, represents, I'm sorry, the old highway represents 4G, while the new highway represents 5G. The problem is that the new highway isn't completely finished. Some parts are ready, while other parts are still under construction. Because of this, your vehicle still needs to use both the old highway and the new highway to reach its destination. This is essentially how 5G NSA works. Your device uses both the existing 4G network and the newer 5G network at the same time. This is where ENDC comes in. Think of it as an intelligent traffic management system that coordinates traffic between the old highway and the new highway, helping data move efficiently between the 4G and 5G networks. If your phone or modem is connected to 5G NSA, chances are it's already using ENDC behind the scenes. Next, we have 5G SA, which stands for 5G standalone. Going back to our road analogy, imagine the new highway is finally complete. And now you can travel entirely on the new road without relying on the old one. That's essentially what 5G standalone is. Your device is connected directly to a pure 5G network without depending on 4G infrastructure. One major advantage of 5G SA is support for more advanced features, including carrier aggregation. Carrier aggregation, or CA, is another traffic management system, but instead of directing traffic between old and new roads, it combines multiple 5G lanes or highways together, This allows more data to travel simultaneously, resulting in higher speed and better network performance. A common misconception is that if a device supports 5G standalone, it automatically supports 5G carrier aggregation. That's not always true. Carrier aggregation is a separate hardware capability. Many early 5G devices, especially those released before 2024, support 5G SA, but may have limited or no support for 5G advanced 5 for advanced 5G carrier aggregation features. Finally, we have the latest evolution of 5G, known as 5.5G, 5G Advanced, or 5G Plus. The name varies depending on your device manufacturer and your network provider. You can think of 5.5G as an upgraded version of 5G that improves speed, efficiency, latency, reliability, and network intelligence. One of the key features of 5.5G is the expanded use of carrier aggregation, allowing devices to combine even more 5G channels and spectrum bands at the same time. Advanced network optimization, including AI assisted network management, also helps improve performance and efficiency. In theory, 5.5G can achieve download speeds of up to 10 gigabit per second and beyond under ideal conditions. In real-world testing, several Malaysian telcos have demonstrated multi-gigabit speeds in controlled environments. However, everyday user will typically experience much lower speeds, often ranging from a few hundred megabits per second up to around 1 gigabit per second, depending on factors such as network congestion, signal quality, tower density, available spectrum, and the capabilities of their devices. At the end of the day, having a 5.5 capable device doesn't automatically guarantee extreme speed. Your experience will still depend heavily on your local network infrastructure and how well your telco has optimized the towers in your area. Now that we have a basic understanding of what 5G is and how it has evolved over the years, let's talk about what the Nokia Fastmile 3 is actually capable of. The Nokia Fastmile 3 is the third generation model in Nokia's Fastmiles lineup, and it was originally released in 2021. Because of its age, it supports both 5G non-standalone and 5G standalone. However, this modem was released before many of the newer 5G technologies became widely available. As a result, it does not support 5.5G, also known as 5G Advanced, and it has limited support for modern 5G carrier aggregation features that are found in newer 5G hardware. When it comes to signal reception, the Nokia Fastmile 3 features a high gain built-in antennas with gains of up to 11 dBi. During the initial setup process, the modem automatically selects the antenna orientation that provides the best signal quality. If needed, you can manually rerun the antenna optimization process using LCD screen located on top of the modem. Speaking of automation, this modem relies heavily on an automated network management system. In simple terms, the modem's hardware, software, and modem chipset handle most of the communication, and negotiation with the cellular network automatically. While this makes the device very easy to use, it also introduces one major weaknesses. The user has very little manual control. Unlike many Huawei ZTE or industrial grade 5G routers, The Nokia Fastmile tree does not allow users to manually log specific frequency band, manually select a cell tower, force a 4G only connection, or choose between 5G non-standalone and or 5G standalone. Essentially, the modem decides these things on its own based on what it believes is the best connection available. While researching this modem, I came across a few community discovered workarounds. One suggestion was to place the modem in a location with weaker 5G standalone coverage, such as a basement or an area with significant signal obstruction. The idea is that if the 5G SA signal becomes weak enough, the modem may fall back to a different network configuration, potentially allowing it to connect through a 5G NSA instead. Unfortunately, I wasn't able to test this myself because I don't have a basement, so I can't confirm how reliable this method actually is. I also found discussions regarding cell tower selection. Some users claim that rotating the modem by approximately 45 degrees can sometimes encourage it to connect to a different tower, particularly if multiple towers are providing similar signal strength. Again, I wasn't able to properly test this. In my case, the nearest tower is only about 450 meters away, while the next closest tower is several kilometers away. Because of that huge distance, and the signal from the nearest tower is simply too strong and tends to dominate the connection. If you're experiencing a similar issue and absolutely need to connect to a different tower, the most practical solution would be to install an external outdoor antenna and point it directly toward the desired tower. Interestingly, the Nokia Fastmile tree can be modified to support external antennas. However, this requires opening the device and performing physical modification because the modems does not come with external antenna ports from the factory. Before I begin talking about performance, I want to make one thing very clear. When it comes to wireless broadband, your experience depends heavily on your local network conditions. Factors such as tower density, network congestion, signal quality, and how well your telco has optimized its infrastructure all play a huge role in determining the speeds you'll get. At this point, 5G deployment in Malaysia has matured. Most telcos are now focusing on maintaining and optimizing their existing networks rather than rapidly expanding them. On top of that, 5G adoption has increased significantly, meaning there are far more users sharing the network compared to when 5G first launched. Because of this, I don't think most users should expect the crazy multi gigabit speeds that were often showcased during the early days of 5G deployment. That said, I can't comment too much on the performance difference between sorry, between 4G, 5G non-standalone and 5G standalone because my Nokia Fastmile 3 is currently logged into 5G standalone most of the time. Since I have no way to manually force 4G or 5G non-standalone mode, all my testing was performed on 5G standalone. Before looking at the speed test results, there are two technical details worth mentioning. First, the nearest cell tower is approximately 450 meters away from my home. However, there are some physical obstruction between my house and the tower, including trees and nearby buildings. Second, after spending quite a bit of experimenting with placement, I managed to find location where the modem maintains a signal strength of below 90 dBm about 99% of the time. During heavy rain, it occasionally drops to around 96 dBm, but most of the time it stays below 90 dBm. The strongest signal I've ever recorded was approximately 81 dBm. Based on my research, 5G standalone signals between 80 dBm and 90 dBm is generally considered good. However, to fully maximize data throughput or transmission, you'd ideally want a signal strength closer to 80 dBm or better, with values around 70 to 60 dBm being excellent. Now, let's get to the part that most people are probably waiting for, the speed test results. For this test, I used two devices, a Huawei P40 Pro and a Google Pixel 7 Pro. Let's start with the results from 26 and 27 May 2026. I choose these dates because they coincided with the Hari Raya holiday period when many people were returning to their hometowns. There was also some rainy weather during this period, making it a good opportunity to see how the network performed under heavier than normal load. On 26 May, download speeds generally fluctuated between 300 megabits to 400 megabits. The the lowest recorded download speed was 161 Mbps. It's also worth mentioning that many of these tests were conducted during peak usage hours when network congestion is likely to be its highest. It's likely at its highest. On 27 May, performance was quite similar. Download speeds mostly remain around 300 megabits range, with occasional drops to around 145 Mbps. One thing that stood out during both days was the upload speed. As you can see from the results, upload performance was noticeably lower than expected. For a healthy 5G standalone connection, I generally expect upload speeds to be at least around 50 megabits or higher and higher. At the time, I had already optimized the modem's position to maintain signal levels of 90 dBm and better. However, this wasn't actually the modem's final current. The modem's current final placement. Later, I adjusted the modem to a slightly higher position and performed another round of testing on 4 June 2026. The new placement did produce occasional spikes in upload performance, but most tests still remain below 50 Mbps. Because of this, I contacted Yes to report the issue and provided them with my results. After that, I conducted another round of testing on 7 June. For the first time, I managed to achieve an upload speed of 53 megabits per second. However, further testing showed that upload performance was still inconsistent. Sometimes it would remain above 50 Mbps, while other times it would drop back to 40 Mbps or even 30 Mbps range. So while there was still some improvement, the results were still fluctuating quite a bit. At the time of making this video, Yes appears to still be performing network optimization or maintenance work in my area. Because of that, I'll probably revisit this topic in the future. It's also possible that adding an external outdoor antenna could improve both download and upload performance. Although that's something I'll need to test separately. For now, I would describe the overall performance as perfectly acceptable, especially when compared to the first few days and weeks after I started using the Nokia Fastmile 3. Let's talk about stability and whether the Nokia Fastmile 3 suffers from overheating or random reboot. In my experience, the modem does get warm during operation, but not to the point where overheating becomes a problem. I haven't observed any performance degradation due to heat, nor have I experienced any heat related rebooting issue. However, I did counter random reboots shortly after I installed the modem. After some troubleshooting, I discovered that the problem wasn't actually the modem itself. The issue was caused by a low quality 10-meter extension cord that I was using. Once I removed that extension and connected the modem directly to a wall socket, the rebooting stopped. Later, I purchased a much higher quality extension cord, and since then, I haven't experienced a single unexpected reboot. So, if you decide to use an extension cord, make sure it's a good quality one and avoid excessively long cable runs whenever possible. As proof of the modem's stability, here's the uptime counter showing how long the device has been running continuously at the time of me making this video. Since this isn't intended to be a full in-depth review, I'll leave you with a quick summary. Overall, the Nokia Fastmile 3 delivers download speeds of around 300 to 400 Mbps in my area, offers acceptable stability, and doesn't appear to suffer from overheating issues during normal operation. However, its biggest weakness remains the lack of manual controls such as band locking, cell tower locking, and the ability to force specific network modes. That being said, despite being released back in 2021, the Nokia Fastmile 3 is still surprisingly a capable modem. It's relatively affordable, easy to set up, and most importantly, it has proven to be dependable for day-to-day wireless broadband use. Would I recommend it? Would I recommend it? If you're looking for a simple plug and play 5G modem and don't mind letting the modem make most of the network decisions for you, then yes, it's still worth considering. However, if you're the type of users who likes to tweak settings, lock bands, or manually select cell towers, you may want to look at other options instead. As for me, I'll continue using it for the foreseeable future, and hopefully its performance continues to improve as the network in my area becomes more optimized. If you have any question about the Nokia Fastmile 3, feel free to leave them in the comment section below and I'll do my best to answer them. Thank you for watching, and if you found this video helpful, consider leaving a like and subscribing to the channel. I'm mresult04 signing off. See you next time.